Hello class, welcome to my lovely abode. I'm not so sure how to start this video, but I was told by an anonymous source, they whose name shall not be named, Dr. Colbert, that essentially the more creative, the more points we could possibly get, and the more room there is for slack. So I'm gonna try and do it this little TikTok style, and I don't know what's a TikTok video without a little bit of background music. And so, let's just get into it. So I'm not so sure how I feel about this title, because it's not necessarily my favorite microbe, but it's pretty interesting. So instead we're gonna call it probably this, because it's probably one I'm gonna hand in the project. But anyway, now this egg-shaped, bird poop, flash-shaped bacteria, whatever you want to call it, that you see above me is known as Mycoplasma genitalium. And it's a very, very naughty pathogen, outside of the fact that it causes human illness. Why, you might ask? It's the latest and greatest, and definitely the trendiest STI inducer that's been sweeping the nations as of lately. And even though we found it just a bit back in the past, it's been ever so common, according to our medical records, within the 2000s, making it a somewhat emerging concern. And this can obviously be due to newer technologies, because even though this bacteria specifically, Mycoplasma genitalium, is a bit of an invasive pathogen, our newer technologies compared to what it was back in the 1900s allow us to evaluate and analyze and isolate this bacteria, which could be a factor in its ever so emerging populace. Now, I know it's a pretty interesting bacteria, but before we go any further, I kind of want to get a quick little relapse on how we got here in the first place and where this whole thing is coming from. Originally discovered in 1981, Mycoplasma genitalium was first discovered in urogenital tracts of humans and later isolated to be announced a new form of Mycoplasma. Now, Mycoplasma, which are the smallest self-replication organisms known in nature, give it up for Mycoplasma, come from a class known as molecules, which are essentially parasitic bacteria in nature. Now, these molecules are known to thrive off of host cells of many animals and plants that favor their respective environment. Mycoplasma specifically are gram-negative bacteria that lack the presence of a cell wall and thrive within the cells and surfaces of organs affiliated with the respiratory and urogenital systems, causing urinary and respiratory tract infections. Now you throw a couple of asexual babies in the mix, peppered with hundreds of years of evolution and time, and just a dash of beneficial evolutionary mutations, and we unfortunately find ourselves tussling with Mycoplasma genitalium. Now, with so many STIs on the market, obviously it wasn't a very easy pathogen to find. So I'm going to try and explain how our friend Joseph G. Telly did it to his best of ability. It's not going to be a very good explanation, but it'll solve its purpose. Now, although Mycoplasma genitalium was first isolated in 1981, it wasn't until 1983 that our boy Joseph G. Telly and his colleagues first cultivated the bacteria by means of a medium. This medium was derived from Mycoplasma broth base, peptone, tryptone, and glucose mixed with deionized water. The base was adjusted to a pH of 7.6 and sterilized. The broth was then supplemented with tissue culture supplement, yeast extract, TC eustolate solution, and heated fetal bovine serum, along with penicillin and phenol red solution. Now, considering that Mycoplasma genitalium, remember kids, is a negative gram bacteria, it can be noted that penicillin was an integral part and key player in the broth. This is because penicillin often works against bacteria with cell walls, attacking their peptidoglycan layer. Thus, it was an effective way of isolating it from other growing bacteria and STI inducers. The broth was lastly prepared as a solid medium after mixing noble agar and agarose to the base. Two Mycoplasma strands, known as G47 and M30, retrieved from genital epithelial cells belonging to the urogenital tracts of two NGU-inflicted patients, were grown in SP4 medium in T25 tissue cultured flask and incubated horizontally. Growth appeared on the flask and the medium was drained, and growth was scraped, put through a membrane filter with a pore size of 220 nanometers, and inoculated onto the agar cultures and incubated. These steps were repeated 2 more times through tenfold dilutions using the new bacterial growth. There, strand G37 was observed to change into a bacterial form, and thus a suspension of strain G37 was grown in 3 different flasks containing thallium series, polymyxin series, and control SP4 medium, and incubated aerobically for 28 days, noting pH changes from red to yellow in the SP4 broth. From there, Joseph and his colleagues observed the morphology of the strain G37 under electron microscopy using negative staining procedures and sectioning techniques. Now, I know I kind of got into the where Mycoplasma genitalium came from, or should I say the when, but I never actually said why it was such a concerning, or at least interesting, bacteria. So take a dive with me. So I already mentioned this previously before, but just to recap, Mycoplasma genitalium is a lesser-known sexually transmitted pathogen that lives in epithelial cells that secrete mucus in the genital tracts of humans. It's also one of the leading bacteria responsible for NGU, or non-gonococcal urethritis, in men, and a whopping 25% of cases involving cervicitis and pelvic inflammatory disease, or PID, second and third to chlamydia inducers, that is. Urethritis, cervicitis, and PID are essentially inflammatory conditions in the respective locations, obviously the urethra, cervix, or pelvis, that are commonly found in sexually active humans. They're basically the proper term for that burning sensation STIs are so famously known for. Mycoplasma genitalia is quite different in retrospect to the other STI inducers, with its susceptibility factors that can be seen as both beneficial or worse than others depending on who you ask. For starters, transmission is primarily genital-to-genital contact, so this means that essentially it's a bit less susceptible to transmission than gonorrhea and chlamydia producers. But unfortunately, the good news ends there, as among reported patients, 40 to 75% of known M. genitalium infections are asymptomatic. Not only that, but it's been recently discovered that M. genitalium are also biofilm producers. And if you paid attention to the latest chapter in the textbook, that's a no bueno. Essentially, they act not only as protective shells against biocides and a variety of our antibiotics that already had trouble defending us against negative gram bacteria, just like penicillin, but also as a cloak from our immune system responses. So at the end of the day, when you add these asymptomatic symptoms and multiply it by the defensive mechanisms that come naturally to M. genitalium, this is all nothing in short of a bacteria-filled turmoil sandwich with a side of prokaryotic disaster fries. It's really your worst nightmare in the form of an STI. So I kind of found this diagram that gives a good idea on how to conceptualize just how dangerous bacteria can be to us humans, specifically in women, but you can kind of translate the context to men if you understand the anatomy well enough. The pathway of infection of N. genitalium starts in somewhat of a single-filed line correlating to how long the bacteria has been growing, depending on the severity of one's condition. M. genitalium starts off carried through by sperm in the vagina, where the bacteria settles and colonizes, starting us off with our first diagnosis, vaginitis. After a certain period of time, M. genitalium travels up the reproductive tract to the cervix, endometrium, and fallopian tubes. From there, cervicitis and endometriitis can be contracted, causing cell swelling, shedding, and releasing inflammatory factors, which initiates inflammatory reactions. Further consequences of their growth and shedding of cervical epithelial cells might lead to induced adverse pregnancy outcomes. Even without inflammatory symptoms, growth of M. genitalium can end up blocking fallopian tubes, causing unforeseen infertility and skewed results. Long-term infection with M. genitalium inevitably leads to chronic inflammatory responses that may be associated with mass formations that develop into possibly ovarian cancer. But that's the worst of the worst.